Hi, everyone. Thank you for coming in. I'd love to see a large crowd like tonight. We had how many people have never been to PyCon before? Raise your hand. Wow. All right. How many people, just to inverse question, ask the inverse question, how many people have been to PyCon before? Cool. So there's actually more people who have not than there have. So we want to share this experience with you a little bit. And that also means I'm going to take a couple of moments just to quickly explain what it's like. PyCon is one of the most fun things I've ever done, and I do it quite regularly. Last year was actually, I had to use a passport because it was actually in Montreal. And why I like it so much, not only is there talks, but there's a great place to socialize. And there's really kind of a theme of things. One, you see some really excellent talks. We have some great speakers tonight, people I'm really excited to hear from. But you also have things where people say, look, I want to talk about something else. I want to have an unconference on something. So you have a little board and you write things down and you go stick it up on this board. And if you want to talk about how to debug something on a Raspberry Pi, there's a whole group that would do that, or whatever you want. So it's very creative that way. You also have lightning talks. We have a really fun lightning talk tonight, and it's a very short 5-minute talk to share that as well. But you also get to see people you haven't seen in a long time. If you like open source programming and coding with other people, a lot of my friends from the UK, for example, I don't get to see them very often, but they're always at PyCon, so that's really fun. And then there's also tutorials. If you show up ahead of time, you actually there's an extra fee for that, but you actually get a chance to learn some great things. You actually sit down, take classes, and learn things from other people. And there's also the sprints. And sprints are a part where you're going to say, okay, I'm going to help with an open source project, get all of these people together who are doing open source, and let's just code together and see what we can do to help out. And there are probably a few other things about PyCon that I haven't mentioned that I've just forgotten. Anything else that's major, that's great about PyCon that someone wants to say?
This year and next year is in Portland.
That's true. Let me make it very clear. Even though last year was somewhere else, this year is so close we have to go. It's in Portland. Great. Thanks, Alex. Anything else that I missed that I should say?
Parties.
Oh, there are parties, of course. And there's an auction. There's the PyLadies auction, which is really fun. Yeah, and there are parties. People have these great social parties all the time. Charles? Yeah, there's sprints. If you want to sit and code together, people code as well.
Job fair.
Oh, of course. Job fair. There's a job fair there with lots of booths. And there's a poster session. So people come around and do poster sessions. Did I forget anything else? That's a lot. Yeah, that's true. Summits as well. So we couldn't bring all of that to you tonight. That would just be a lot for our night. What I wanted to do was actually do a little tutorial for 15 minutes and then do a little sprint afterwards. But I found that everything I wanted to squeeze in was just too short. So I won't try to squeeze it all in. Let's just get the highlights. So let's start tonight with Alex, who's going to be speaking. Alex is an awesome speaker. He's someone who I actually come and always look for. Him and Guido are some of my favorite speakers we ever have. And so Alex, I'm going to let him introduce himself so I don't take all that thunder. He's going to come tell you some great things about exception handling, Python 2 and Python 3.
Thank you.
Thank you.
Is my mic on? Can people hear me in the back? If you can hear me, wave. Well, some can, some can't. All right, so this URL, which has been up for hours now, is where you can get the PDF of these slides. So I won't repeat it. And besides my employer, I need to spend a minute showing up my book, which is not just mine. It's a Python community's book. It's my wife Anna's book, Steve Holden, founder of the PSF and of PyCon actually, and it's already there online for you, and that particular URL gives you a 50% discount on DRM-free ebooks. Only 40% on the paper version. Sorry, I couldn't. I tried, but I couldn't have them get it down to 50%. Each author is separately a PSF fellow and a winner of the Frank Willison Memorial Award for contributions to Python. This talk is a summary, short summary, of chapter 5, which is already complete and online. And if you buy the ebook today, you will get all updates all the way to the final edition. Exceptions are very common in Python. They don't only correspond to errors. Of course, if you make an error, say 1 divided by 0, that will be an exception. But something that's fully expected to eventually happen, like an iteration finishing, will also raise an exception. Note the difference: stop iteration versus 0 division error. The name of the type that's raised as error if it's something it shouldn't happen in your program. It doesn't if it's something that's fully expected in your program. Throughout the slides, I will use EXE as an abbreviation for exception. The core thing, if you only retain one thing from this talk, should be the try statement. Yoda says there is no try, just do or do not. I disagree, at least in Python. There definitely is a try. And it's a try block, and then you follow up with clauses with catch exceptions. You can have a single type or a tuple of types in parentheses. Else, meaning no exception has been raised, and I want to execute the rest without any guard against exception. And optionally the finally, which means no matter what has happened, exceptions or not, at the very end, do this. 2 bits. Errors that are commonly made. If you have more than one except, they're tried in order, first to last. The first one that matches the type of whatever is happening catches it, and no more attempts are made. Therefore, if you have a broader one and a more narrow one, the more narrow must be first. People often get caught into that because they reason in their own logic, but it doesn't get the most specific, it gets the first that matches. Another thing that's not immediately obvious, don't have break or return in the finally clause. If you try to put a continue in the finally clause, Python diagnoses that for you as a syntax error. But if you put a break or return, that's not a syntax error, but you should never do it because it will conditionally execute. Remember, finally always executes, and if an exception has been raised and has not been handled, that will swallow it. It will make it silently disappear, which no reader of your program could possibly expect. So just don't do it. Still hope didn't make it for 3.5, but to get break and return to also be considered at least a warning, but an error would be better in 3.6 or 3.7 or some time, because it makes absolutely no sense to have them. So try is how you catch potentially and handle exceptions or do cleanup in a finally. The counterpart is raise. Raise some exception object causes that object, which must be an instance of some exception class. So instance of base exception in Python means of that class or any subclass. That starts to propagate. In version 2, by which I mean 2.7 and previous ones, you could also raise a class, a subclass of exception that makes no sense. Remember, one of the principles of Python is there should be only one way to do things. So people came to me and asked, okay, so what's the difference between raise foo error and raise foo error open close? That is, raise the class versus raise the instance. And I had to say, there is absolutely no difference. They do exactly the same thing. It's an absolutely arbitrary distinction. So finally, we managed to get away from being able to raise a class. You can also raise without any argument. In that case, you must be within an except clause. or a function that's called directly or indirectly from it. This essentially re-raises the exception being handled, which is often what you want to do. You want to try, blah, 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 accept something, clean things up, make a log, and then raise again, because you're not really handling the problem. You just want to make sure that some cleanups happen. So when do you want to do that? Well, I'm an old-fashioned guy, played 5-card stud. If I had that, I'd probably raise. But in Python, the concept is slightly different. Consider this example. I want the cross product of two sequences. In real life, I'd be using iter tools and so on, but just to show off, I'm doing it in a simple list comprehension. But for reasons connected to the semantics of my specific program, I want empty arguments, empty sequence arguments, to be errors, which they wouldn't be. They would just return an empty cross product. That's normal semantics, but I want them to be a value error. So I specifically test for falsehood of either, in which case I raise. Note that I'm only checking for stuff that Python isn't already checking for me. It makes absolutely no sense to duplicate the checks that Python is doing anyway. As in, are they iterable? Well, if they aren't, this will raise, presumably, type error, which seems just about right. You only need to add the checks for stuff that Python would pass silently, but your own program semantics considers errors. In V3, we finally, by V3 I mean 3.5, but that also applies to previous ones, such as 3.4. I believe all I'm saying about in this presentation does. We finally acknowledged that you can never be pessimistic enough. While you're handling an exception, you might happen to raise another one. What happened in V2, in 2.7, or previous, is that the newest exception overwrote the old one. So the old one, the one you were supposed to be handling, disappeared from your tracebacks or everything. Now, in V3, first of all, the traceback is held by the exception object. So if you ever need to change it, there's this with traceback method that gives you a copy with a different traceback. Possibly more important, the last exception code that you were handling becomes the dunder context for the one you raise or happen to trigger. Dunder, by the way, is normal Python way to pronounce a double underscore, context double underscore. We save several syllables, and they mount up over the years. And you can also raise a new exception from the old one, and this sets a dunder cause to explain that the previous exception is the cause of the new one. So, for example, say I have a function inverse which just returns 1 divided by the argument, except in the case of zero division error, I want to diagnose that as a value error. Value error means the type is correct, but the actual value you passed isn't. So that can make sense in some context. So I raise value error from the zero division. So therefore, Python will display as default error message that first the zero division, and then it will tell you the above exception was the direct cause of the following one. Note that in terms of handling things, what propagates is the value error, the one you explicitly raised. The other one is there as a dunder cause and available for clearer diagnostic. And here's a context example. Here I just make a mistake while trying to handle an exception. I'm trying to sum an integer to a string, which is an error. So in the previous one, I would only get the type error from this In version 3, it starts by telling me I had a zero division error, and then during handling, so not as a cause, but as it happens, of the above, the other exception occurred, so you get both by default. As an alternative to finally, more often than not, you may actually want to use a with statement, a context manager as it's called. The X you're withing is known as a context manager. It means something with an enter method and an exit method. The enter method is called to enter in the context of this block, and it can return the value that you use in the as something. Then the block is in a try finally, but with an except as well, because if anything happens, note except without any qualifications catches anything, so it's very important to re-raise it. Then it goes to the exit method. sysexinfo is how you get the exception in any context whatsoever. And your exit method can return a true value to say everything's been handled, everything is under control. But if it doesn't, if it returns a false value, then the re-raise occurs. If no error has been there, then your exit is called with 3 nones. How do you make a context manager? Well, one way is, of course, to code a class with dunder exit and dunder enter methods. That's often the best way. But since it's such an important task, there's a context lib in the standard library whose decorator context lib context manager abuses, some would say, a generator. This must be a generator with a single yield, and it needs to provide its own try except finally. The point is, whatever happens here is the dunder enter code of the resulting context manager, and whatever happens here is whether it happens if any exception has been caught, and this is unconditional. So you may need to also check. Why is it important to distinguish whether something has been raised or not? People with C++ in particular experience are very familiar with the idea that resource acquisition is initialization. You make a type, you put it on the stack, its destructor, which will automatically be executed, does the cleanup whenever you're done. That's good as long as the cleanup you want to do is unconditional. But a common idea, for example, might be, say you're wrapping a database. If everything goes fine, you want to finish up with a commit. But if something's gone wrong, you want to roll back. That's trivial with the exit, which is past the error information. It's very subtle if that wasn't the case. So this is better than resource acquisition. Exception can now also occur or be caused explicitly by you inside a generator. Specifically, generators now have a throw method. Throw method takes the exception, and from the generator's viewpoint, generator is in general stopped at a yield, waiting for the yield to give a result. And if you instead call generator throw, there an exception is raised. So you can try except, finally, whatever you need to do to handle the case. In particular, by far the most common exception you may want to raise is generator exit. Note it's not an error. It's expected that the generator will eventually exit. And instead of explicitly throwing generator exit, you can call generator close, which does exactly the same thing. Okay. Assume you're all familiar with exception propagation at the stack of calls with finally closes getting executed as things bubble up and potentially all the way to the top, and sysexcept hook is how you may change the diagnostics when you're all done, instead of Python by default shows the traceback and things. Just remember, if you use the attexit module, anything you've registered with attexit runs after the destructions and the accept hook. I'm skipping this because this was originally a 1-hour talk. That's what I had at PyCon Italia 7. This was a keynote. So, given the way try except works, it's very important to be familiar with the hierarchy of standard exceptions, because if you catch, for example, try except standard error, anything deriving from standard error will be caught. So, 2, we had exception and then the specials, generator exit and so on. It always was hard to explain why stop iteration here while generator exited there. Well, because I mean I couldn't justify it. So essentially, the yellow stuff is the core stuff that's changed, as I will show. Standard error and environment error are gone. Actually, the term is still there, but it's just a synonym of a standard name. While this has been all simplified, OS error, which is now a synonym of IO error and environment error, have spawned many subclasses. For example, if the specific error is that a file was not found, now you can get a file not found error. Why doesn't this break your code which does try except OS error? Anybody wants to volunteer an answer? Well, I had to try OS error, except OS error, but now it's become a file not found error. This will break me, right? Or wrong? Why not?
It's a subclass.
The point is, when you catch OS error, you catch any subclass thereof. But why is it good? Well, because in version 2, or actually 3.031, I think 2, you had to typically catch IO error and then start looking at exactly what happened. What's the error number? For example, here we want to single out the file is not there, because in that case we want to return a default value. But if the file is there, but I can't, for example, I don't have permission, that's a different problem that I'm not expecting, and I would just like it to propagate, therefore I use a erase. In version 3, you just catch the specific file not found error, everything else isn't caught, so it just propagates without problem. So there's plenty of standard errors. Should you, standard exception classes, should you make your own? Yes, you should. Whenever you write something that's a library, modular package intended for other people to use, consider having a custom error class from which you derive all of your exceptions that are errors. This makes it very easy for anybody using your library, client code as we call it, to catch errors specifically if generated by your package. Plus, this is very unusually seen, but I'm a paladin for it. There's a reason Python has multiple inheritance. You can derive your exception class from both your own modules, error, and some standard, such as some standard exception class, such as type error. This way, if the user code, if the client code wants to catch any type errors, it can just do except type error. If it wants to catch any error from your module, it can just do except your module.error. Either works. That's one of the best uses of multiple inheritance I've ever seen. Now, finally, this is the tactics of it. Should I take questions on all these now, or at the end?
We have a place for questions at the microphone. If you want to ask, if you'd like to have them questions now, you can. If you want to wait.
If anybody has questions specifically on the tactical parts, which I've presented so far, otherwise I can go on the strategic parts, and then we can have all the questions at the end. Okay, let's do that. So, there are two main strategies for handling errors. I've named them look before you leap and easier to ask forgiveness than permission. I never spelled that out, but I have here. LBYL, EAFP. EAFP, of course, is the motto of what I personally consider the greatest woman who's ever worked in computer science, Grace Murray Hopper. I have a whole presentation called Forgiveness or Permission, which I'm sure you can find, which starts with singing her praises. But this is specifically applied to Python exceptions and errors. In the look before you leap approach, you first check that every prerequisite is satisfied. If not, then you raise exception or otherwise signal errors. If everything is fine, you finally go ahead and do things. In the easier to ask forgiveness approach, you just try to do it. If something goes wrong, Python will catch you for it. Will catch the error for you. You may want to catch that exception and then do more diagnostics, but the core of the operation is on Python's shoulders. Why doesn't LBYL look more reasonable, sensible? I mean, after all, if you are crossing the road, you first check no car is coming, and only if that is the case, you cross. You don't just try crossing, and then if somebody runs you over, you'll sue. That sounds not... well, in programming, it's a bit different. First of all, look before you leap duplicates a lot of work that Python will perform anyway. So if you, for example, are worried about divisor being 0, checking if divisor equals 0, raise something else, return 1 divided by divisor, well, that divide will check again what you just checked. I realize machine cycles are cheap, but why waste them? Waste not one, not. Python is going to do the check for you. Why do you feel the compulsion to repeat it? That also obscures clarity. Instead of, if you're checking for many things, if this condition isn't satisfied, oh, woe is me. If this other condition isn't satisfied, oh my poor self, blah, blah, blah. After 17 lines of error checking, you finally come to the point of what is this function intended to do, besides raising exceptions if it meets errors. By the time your average reader will have turned to a video game or your code reader. And not just the current generation often accused of having a short attention span. I would too. Having everything obscured by a barrage of checks and the actual work, the actual purpose of your code only at the end is a recipe for obscurity. And I said you were supposed to do 17 checks. You sure you didn't skip one? Oops, I only did 16, so that the unexpected exception actually happens and you're not catching it, you're not doing anything. Disaster. The more things need to be correct, the worse off you are. Plus, especially if you're working on the file system or in any kind of multitasking program or on database or on anything that's not like totally hermetic and isolated to you and you only, things may change between the moment you check and the moment you operate. The check you just did might not be valid anymore. Consider this is the same example I had before. Read the file, but if not present, give me a default value. This is a typical LBYL approach. If it exists, then open it and return, otherwise return the default. There are many problems. I'm not going to. But the core one, the fact that it exists at this time doesn't mean it still exists at that time. A file system is shared between multiple processes running on the same machine. You cannot stop other processes from deleting the file you just so carefully checked existed. You don't care whether the file existed at this time. You want it to exist at this time, and you can't ensure that except Python checks for you. So why duplicate it? Just try opening. If it's a file not found error, well, then that's a case of the default. So EFP is better. However, it's not a panacea. You can easily use it wrongly. It's so good once you get used to it that you may easily overuse it. Use it on too broad a range. Consider try call function, which tries to call a method with a certain name on an object, but if not present, returns a default value. Then a natural but wrong way to do it is to have the getUtter to fetch the method and the call both in the try clause, single statement. Get the attribute error, which getUtter would cause if the attribute so name wasn't present, and return default. Problem is, this goes way over the function specs. If the method is there, then getUtter is fine, but then inside the method there's an error, which causes an attribute error. You're catching it, hiding it, returning the default. That is not the function specification. That is not what you want to happen. You want to diagnose and fix your bugs. So this is the way to do it. First, you do only the getUtter in the try. That is where you catch the attribute error. This, thanks to the else clause, is not under any exception guard. Now, you may point out, well, if I didn't have the else, it just aligned return together with try, it would work the same way. Why is it better to have the else? Anybody wants to try? Try import this at your friendly Python prompt. What does it tell you?
It's cold.
Explicit is better than implicit. This explicitly tells the reader this only happens if nothing has gone bad. So it's important to use else when that's what you mean, rather than just rely on the default behavior. Now, I'm saying errors. I should really be broader and say exceptions, because I already pointed out at the very start, not all exceptions are errors. Before you start handling things, try except, blah, 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 consider all possible causes, at least broadly. Don't have to. Are there bugs in your code? That's absolutely crucial. You want to catch them. You don't want, you want to like see a clear diagnostics. Don't want to swallow. Error should not pass silently unless explicitly silenced. Another entry in the import this to the Zen of Python. There could be problems in code you use. You trust it. It's a good, mature open source software. You've just downloaded it, installed it. It may not be perfect. Make sure you have unit tests covering all of these oops things. What about the code you downloaded works just fine, except it doesn't work the way you thought it would. There are slight differences. Maybe its documentation is not perfectly clear, or maybe you were in a hurry, didn't read it well. Whatever, there's a mismatch so that things don't work. That's what integration tests are for. So don't use try except instead of testing. Try except is how you make sure that things that can happen will be handled appropriately and not just crash everything. Last but far from least is invalid inputs to your code. If you're a really good programmer and have done your homework with tests, those will be, and the invalid environment and so on are essentially the same things. They're not explicit inputs, but if your program relies on the certain configuration files with a certain structure and the user hasn't put them in place, that's like giving a wrong input. Why are these the most frequent? Because we're still on release 1.0 beta of human beings, and the upgrade seems to be a long time coming, as happens sometimes to beta programs. So expect errors there. That possibly the single best use for try except. You don't want the user to crash your program because they made a typo. Be nice to them. And remember, Python is going to be able to catch most of those for you. However, also, when that happens, remember a crucial thing. The information you need as the coder to understand and fix any bug you might have is not the information the user needs. Okay, out of all of my pet peeves, possibly the worst is when a program, typically on a behind a web page somewhere, shows me a core dump, or sorry, I mean a traceback. It's usually Java, which already makes me nervous. But even if it was Python or what have you, what can I do with it? What am I supposed to do with these 15 lines if Python, 115 if Java? Besides curse at them. If your programs ever show the user, the end user, I mean, not you while developing, a traceback, you're doing it wrong. That traceback has information which you as a developer can use to understand exactly what went wrong. So save it somewhere, send it to yourself. Remember to ask the user for permission to do so if it's on their machine. May I please help debug this, blah, blah, blah. For the user message, design it carefully. It's a crucial experience for the user. You will have errors, but I have a different talk, which I also presented at BayPiggies, called "There Will Be Bugs." I'm not going to repeat it, but it's a bad time for the user, so give double attention to it. Focus on what can the user do at this time, because a traceback tells them nothing. Please make sure your phone number is correct is better than nothing. It's like if the problem could be caused by a misformatted phone number and so on. Worst case, please apologize me. Please forgive me. I'm a terrible programmer. I have a bug. That not much, but it's better than a traceback. Sometimes think, okay, I've caught the bug, I've given a good message, I've saved all the information for, now, do I just continue running this program or restart it from scratch? If at all feasible, please restart. You can never be sure. It's a bug somewhere that you didn't expect, so you can never be sure you've done all the cleanups you wanted to. Let the operating system do it for you by restarting, ideally with a little extra program that only does that, a watchdog that makes sure your program is okay and restarts if it's not. If you have snapshot and restore, that's better, but we don't really have the time to get into it. Log a lot, log everything, including non-error cases. I've seen people have problem diagnosing, okay, so this is the log for the crash that I don't understand. Okay, so what would the log look like for a normal run? Oh, I don't know, I wouldn't log anything then. Okay, now you're really making it hard on yourself if you don't have the base case. But this would give me a million lines of logs. So what? You're not supposed to spend your time on Earth manually reading logs. Make your logs machine readable and write the scripts that parse the logs and identify an error or the most recent error or the most recent normal run, whatever. It's like invest 2 hours in developing the scripts, save yourself 22 hours in parsing through the logs. Once you've done this, default to logging everything. You never know if it's a bug, there's something you had wrong, what information will help you diagnose it. So when in doubt, log it. If you're not in doubt, log it anyway. Thank you. And remember, not just errors. Last but not least, if I ever see another assert, I will be seriously angry. I've actually been subjected to asserts very recently. It looks like the best way to check things, right? Inputs, are they valid? It's not. It's an attractive nuisance, I think is a legal term. Because as soon as you run with -o, it becomes an operation. That's what it's meant for. So it's intended for you to use while you're debugging your program. It make sanity checks and make sure you're not completely off the bat. And now you're fully debugged. -o. Assert, my input is valid, is an operation. And remember, you have debugged your program, maybe. You have not debugged your user. Remember 1.0 beta and still pretty buggy? That's you cannot ever guarantee that the user hasn't gone totally that crazy. Use only for sanity checks on internal state fully under your control. It's nice because then it reads as very clear documentation of what you know is the case there, but it's mostly intended while you're developing and debugging. Assert, the input is valid, is the worst code smell you can perpetrate in Python. Don't, please. All right, so this is, again, the URL for the PDF. This is the URL whereby you can get a 50% discount, but the 50% discount isn't the main thing. The main thing is that if you get that and send me feedback, aliax@google.com, I should have repeated that here, I can still fix it. The final edition will be, I don't know, 6 months, after which I will be allowed to handle errata. But say I'm covering these 6 frameworks for web applications, and you absolutely want to tell me, you should also cover the 7th one. If you buy the book and tell me now, I can still fix it. I can at least consider it. If you wait until the final edition is out, which saves you nothing, actually it loses you these discounts, then no way my editor will let me add stuff like that. And the same goes for a million other things. So please give me feedback now. That's the reason I've really, with Anna's taking point and leading, fought with our editor to have this discount to encourage everybody to get it right now. Because I need your feedback. Yes?
By the way, we need your feedback. Not sure if that is good.
Anyway, we've got 5 minutes for...
So you probably didn't know, but there's a quiz coming up. Did I forget to tell you guys a quiz was coming up? So who knows the Zen of Python? Was that the quiz, maybe? Oh, people are already raising their hand. That's good. No, actually the quiz is, and you might appreciate this, name, and there's a prize for the quiz. The whole point is we have this wonderful t-shirt that we are going to give away. Alex brought this back, and Anna brought this back, and he wants to give it to one person. He has one t-shirt, so how are we going to fairly give that out? Asking a quiz that's, that It takes enough interpretation that Alex is going to be the judge of the width. All right. So name 3 programming tasks that Python would not be good at, or not be good for. Did I say that right? Name 3 programming tasks Python would not be good for.
And please use the mic
Please walk
so everybody can hear you.
It's a great shirt.
It's a hard question.
It's a hard question. I want to walk back there. I kind of want the shirt. Oh, okay.
Are you coming up to answer? Or maybe they're getting pizza. They're getting pizza.
Come on, 3 tasks. You can come up with those.
So my first guess would be Python would not be good for device drivers. Because the response time has to be so quick, and you need to have that small level, and it's just not really built for it. Although I saw a talk of Python a couple years ago where someone did something very interesting with that. But anyhow, that was my guess. Someone else? Come on, you can't let me have the shirt. It looks really cool.
Oh, that's 1. You couldn't win with just 1.
Oh, I get to. Oh, I'm supposed to say 3 things. Oh, not that I'm on the spot or anything. Oh, yeah.
Off by 2. We're programmers. We forgive off by 1, but off by 2 is too bad.
All right, we got another person coming.
Okay, let me quickly think, though. I'm on the spot. So other things Python would not be necessarily good at. Programming things that require great GIL things. I got a little cheat from the audience, but I'll share the shirt with you.
That require what? Sorry?
Multitasking. Sometimes some certain GIL things might be not necessarily good with Python. A little controversial. We'll have Dave Beasley kind of weigh in on that one sometime. Good. What was else?
That's not clearly what, because that's not enough.
Thank you.
But thank you very much for the help. And the last thing I will say is, if you really want something that's really obtuse and large and crazy, Python's, or if you want something that has so many different ways to do something, you can't just have one, Python's probably not the best tool.
Okay, let's get the alternatives answer. Oh, by the way, you're allowed to repeat some of his points. That's why I'm asking about 3.
So I'd say anytime that you're dealing with strange hardware, like when you're walking down to a GPU, Python has its own ideas of what classes and structures are going to look like. That's going to be a problem. A lot of times when you're interfacing with a large native library set, like say a large database system that has long since decided what its own idea of a character is going to be, or that when you get Unicode in, you'll never get the same Unicode back out, and that will break it. So that's one spot. And then I'm going to just have to throw in the obligatory for IT operations at major search companies.
So similar to everybody else, this is applications that have problems with things that Python doesn't do well. So numerical methods, if you're doing something that's trivially parallelizable and CPU bound, numerical methods like CFD and finite element analysis aren't going to be great in Python. Additionally, graphics programming, so 3D where you have a really tight loop, are going to be difficult in Python. And cryptography is also going to be difficult for the same reasons.
That's what you... The extensions doing all that are part of the Python ecosystem. And so the 2 best keynotes at PyCon Italia Sette were about gravitational waves, where Python was core to the discovery of gravitational waves because of its strength, and I mean, of course, with NumPy and so on, in such thing as numeric processing and graphics. So. But it's Python is what everybody in science is using in Virgo and LEGO and so on. Anyway, anybody else?
Let me think. Multithread, like excessive multithread in the processor, and heavy math operations that could be a little bit slow, and excessive metaprogramming that Python does not allow us to do, things like Ruby that can redefine as we enter strings or variables at the console.
I'm not quite sure what task would actually require you to change, for example, the meaning of equal on strings, which Ruby lets you do. But
I
that's
don't
not
know,
a
but
task.
they have to be a reason to do
No,
it.
there
I
has to be
don't
a
know.
task. What problem in the world are you solving? A task.
I don't know. I have to ask a RIP guy for this.
Anyway, thank you.
We're developing a web application that needs to be responsive, so it needs to work on mobile phones as well as desktop machines. You're better off with JavaScript Angular. So I would use that rather than Python.
Oh, you mean the part running on the browsers? Yes, you have to. That's a valid answer. Because it's on and off, but the web application that's consuming most bandwidth in the world, YouTube, is all Python. But then, of course, there's some JavaScript in the browser, and that's...
If I wanted to make a fortune on a Google phone app, would Python be a good tool? I think it only runs Java in operation, doesn't it?
Yeah.
Android, yeah.
Yeah, you'd have to. So, I believe the same goes for iPhone, even worse, because Apple has a tighter control.
So in my opinion, it's definitely not good for low-level control of like memory control, for instance, that you can do with C, and any even more low-level stuff such as real-time operating systems that you need to deal with, or like low-level programming with kernel, which kind of it's in the same thing. Another thing that I think it lacks, it's a good framework for parallel programming. On large clusters, you have to use something else for that. At least, usually it's used for computation, you use like libraries such as OpenAPI for good communication on that side. So you don't have, like, at least as far as I know, maybe I'm not sure. I didn't see large clusters with that.
I'm thinking of some really big applications such as Instagram using large clusters, or YouTube using large clusters. They're all Python, so I don't really know what you mean.
Yeah, but how you manage the resources then from the cluster? Can you do it with Python?
Mm-hmm. I work for Google Cloud Platform. It's a reasonably large.
Yeah, but you need, I agree. But you have to have additional tools to manage that. They don't come within the Python framework.
Mm-hmm. I use the same G-Cloud libraries that I would have to use from other languages.
Okay, maybe I work. At least I haven't seen that.
It's all REST in the end. So why would Python be any worse than anybody else to address representational state transfer? If the APIs are not REST, they're broken. But that's a different story.
I'm thinking more like, large computation cluster that you use in science, for instance, they never use Python. I mean, at least for large cluster that I've seen, at least in the computation, physics, chemistry, usually there is a combination of Fortran with OpenAPI. And
like the analysis of the gravitational wave event, that's one of the most significant scientific discoveries.
I know there are
unfortunately, it was all Python on a large cluster, so I think your point is not well taken. But by all Python, I do include NumPy. I mean, even Google App Engine, the Python runtime comes with NumPy. It's not in the standard library only because it's changing too fast.
Mm-hmm. Yeah, and the last one was already mentioned. Any low-level stuff related like drivers and similar stuff that was mentioned in the beginning. So that's kind of out of the box. Thank you.
I would think of logic programming, like first-order logic systems, would not be suitable for implementation in Python.
What wouldn't be suitable, I think?
First-order logic systems like Prolog. There used to be a language called Prolog, which used to handle logic. So handling logic...
You mean like natural language processing?
Not exactly natural language processing, but rule-based kind of reasoning, where you have an inference engine and predicate calculus, first-order logic.
What was that? Predicate calculus. Predicate calculus.
Mm-hmm.
So that's one thing I thought. And the other one, of course, is firmware kind of applications, where the software needs to reside on the hardware. So that's the other one. And the third one would be real-time systems or embedded systems, where response time is a priority. Those are the three.
Thank you.
I'll steal the device driver one. That one's an obvious one. Formal systems, anything where you have to be able to exactly trace every execution on a processor, like airplane systems, things like that, would be a bad use. And then like incredibly constrained devices, like programming an FPGA chip or just anything.
Which is exactly what my daughter is doing. Unfortunately, the BBC is launching 1 million copies of a device, launching as in giving away to British school children, which I believe is meant to cost about £5 to £10. And that's with all the peripherals. And the main programming language for it is? You guess? I mean, it doesn't have to be named Raspberry Pi to Raspberry Pi is a. So we have several good thoughts. Oh, more.
Yeah. One more. So I believe Python would not be my first choice in implementing a JIT. Offline web app, I think you could probably do it. I'm sure somebody has done a Python to JavaScript translator layer, but I would not use it.
Yes, pajamas. Let's not talk about it. There's a sad story behind it.
I may be stretching the definition a bit, but typesetting, like typesetting a paper, I would probably rather use LaTeX than Python.
Yeah, that's actually. I think that's a really good one. Yeah.
So the good things I've heard. There may be more new coming, but they came from different people. So I don't know how to assign. But one that's obviously true is a device designed to not support it, like any browser or iPhone or Android device. That's very good. If the device uses all possible efforts to keep Python out, then don't fight City Hall, use a different device.
We have one more, I'm sorry, just because a little bit about the time constraints.
So one would be you need the interpreter. So probably for the startup of an operating system, you might not want it. Another would be, and this is a little bit of a theft because people have mentioned device drivers, but if I was writing something like VMware virtualization, really low-level stuff, that's unlikely. And the third is also a modification of what somebody else said. He made a joke about if you don't want people to be able to understand your code. I would say that there are cases where you don't want people to understand your code because you don't want them to reverse engineer it, or if you're doing encryption or something like that. So again, those are not entirely original. I'm not sure I'm the best candidate for the shirt, but hopefully those are interesting variations on existing ideas.
Right. There's plenty of ways to make machine code from Python. The Python doesn't mean CPython. They, I don't know, Number, for example, will make machine code for you. PyPy will make machine code for you, and so on and so forth. But anyway, I was saying that one good idea was if the device actively tries and succeeds in rejecting you. Second one is if I don't think anybody really put it that way. If you cannot tolerate garbage collection because memory is very constrained. That people mentioned kernels and restrained devices, but didn't hear the focus. The devices where it would be crazy, tasks for which it would be just as crazy to use Java or Go, because they also imply garbage collection. The reasons Rust was invented is to have a modern language without garbage collection. And there's C++ still around, but anyway. So that's number two. As for number three, I believe a lot has been ignored about how the fact that Python doesn't need to run under the CPython interpreter. So
A really good talk last year on that, actually.
So I imagine people assumed CPython when I said Python. We often do. We all often do. And in that case, yes, there were other limitations. But different people brought up the different points, so I don't know. I only have one T-shirt.
Who gets this wonderful T-shirt?
Will the audience vote?
Who actually answered the question, come out over here.
And then we have the...
It's a toss-up.
Or we can have the audience vote.
Thank you all for answering.
Hi. So next up, we're going to have a lightning talk from Lisa Bang. She has a background in bioinformatics, and she's going to talk to you about IPython Notebook. She has about 3 years of experience with that. So thanks.
Thanks a lot, Jeff. So today is just a lightning talk, just designed to give people sort of a quick introduction to IPython. Now it's called Jupyter, IPython or Jupyter Notebook. I just wanted to kind of have a show of hands, though. How many of you guys have used IPython before? Okay. Okay. So I might just kind of. How many of you have not used it, or I don't know? Okay, so kind of a nice mix. So, to start with, I mean, it's kind of a quick talk, but a lot of times, just if you want to try out IPython Notebook, I highly recommend just using a TMP NB server, just to try it out. It'll just open up a new IPython Notebook for you. So part of this. It's sponsored by Rackspace and run by the IPython people. Just a quick background: the IPython Jupyter name distinction is mostly trivial. Although Jupyter is supposed to be the new term that we're supposed to use now, that IPython is not supposed to be exclusive to Python. It's supposed to be language agnostic, and you're supposed to have different kernels and be able to, use it with many different languages. So, you can actually just perform any sort of Python code, within IPython Notebook pretty easily, and the outputs that you get would be the same. The outputs that, the difference is that in IPython, the outputs that you might get might be more rich and might be more detailed. There's also a lot of interesting things in terms of notebook cells. So what I'd actually like to do is switch to my notebook so I can actually show you how this works. Let's go up. Sorry. Doing a bunch of stuff, but in most cases you can see that I'm running a notebook server here under localhost, and when you look at the dashboard, you can actually look at all the IPython notebooks that you might have. So I have a bunch. The green means that these are running right now. And, it shows all the other files that I might have. You can also access other files just to the folders, obviously. But let's go back to the Python code. Obviously, it'll run Python code like normal. But the interesting thing is that I like the fact that if you're forgetting what you're doing, or if you're interested in the output and you're interested in accessing again, you can access it through in and out cells. So, for example, you're interested in your output for 50, for example. It'll tell you what your output 50 was. If you're interested, what did I put in to get that? Then let's just take a look. It should output that. Obviously, the outputs are done already since I've already run the code. This is a history line magic. So we're going to go over more magics later. But basically, line magics will actually let you kind of access what you've been doing earlier. So for example, let's say I'm interested in what I was doing, code like cells 50 to 52. You can enter that, and it'll tell you what you put in and what's going on over here. Another neat thing about IPython Notebook that I use a lot is accessing documentation. So, for example, you have a variable, and you just, did a lot of coding, and then you kind of forgot, what was this variable about? It's here somewhere, but I don't know what it was. First of all, you don't remember the name of that variable, then you can always do tab completion. So let's say, I don't remember. Sorry, this is also a quick ref. So you can bring this up by pressing K when you're in command mode. You're in command mode when your cursor is not blinking here. So let's say that you forgot what this variable is. You press tab after this, and it'll tell you, hey, That's the rest of this variable that you forgot what it was. And then, you can obviously shift enter and you get your output and access it through the other ways that we just talked about. Let's say that, I don't even really, I'm still confused about this variable. You can ask more about whatever you had in this variable. Oh, it's an int. Oh, it's, all this other stuff. And actually, this is really useful when you're talking about different packages. Obviously, with math, it's not a big problem. ArcSine is pretty straightforward. I forgot, what, scikit-learn does with random projection. You can always put 2 question marks at the end, and it'll give you all the details so you don't have to go back and open a new tab or something. Pretty handy. These are cell magics and line magics. So 1% sign means just that's line magic, and then 2% signs is cell magic. Basically, line magics apply for the line, cell magics apply for the cell. It's just a handy way of accessing extra features, I guess. Obviously this is, IPython or Jupyter specific. This is not, pure in Python at all, as we know. Quick Ref will just, kind of give you a quick guide to what line magics are available here. So it's a great way. This is a great way for even beginners to just learn about what's going on. Access. I mean, yes, it's pretty easy to access documentation, but not easy always. But this is a pretty good platform, I think. One cell magic I really like is HTML. So you can do because you can just run HTML code really easily. I put some random HTML code here, but you can actually do more interesting things. There's something with JavaScript I'm going to show later. And this is one of my favorite. This is my favorite feature, actually, being able to use shell commands in Jupyter. I'm running Windows, but I can still use Linux commands, which is amazing. Some people actually use this as their Linux interpreter. What else? I think I don't really want to go over data visualization widgets, but this is a bit of code that I didn't write, but it kind of circulates around bioinformatics circles, especially publication. So you'll see over here that there's a bunch of different outputs. There's also like an NB-convert method where you export your IPython notebook into LaTeX, and then you can actually kind of mess with that code, which is really fun when you wrote your thesis in IPython notebook and you're trying to debug it. But but this bit of code is very handy because it's just basically used a lot for to change IPython notebooks with messy code into actual publication-ready code. Obviously, there's still a lot of cleaning up to do, but if you actually were writing a paper and did, some analyses in the middle and you actually managed to make a clean notebook document out of it, ideally, you'd be able to just, hide the code that you'd want to hide. Obviously, the inputs are hidden, the outputs are, shown, and you can actually do a lot more with this in terms of data visualization. If you use Matplotlib, inline, you can imagine that you could just write the entire paper, export to LaTeX. Unfortunately, that's not flawless, but after you fix that up, you can ideally submit that somewhere, and they might like it because it's entirely reproducible. At least if you have the same environment and all that. So I think that's it for this.
So next up is Dave Sawyer, and he's giving a talk at PyCon about SQLite and the SQLite module for Python. And so this should be about a half hour, including questions, right? Yeah. Okay, great. Thanks.
Thank you, Jeff. Okay, thanks for having me and sticking around for this talk. I really appreciate any feedback you have for me because there's still time before PyCon to make more changes. I don't have a book, but that's the idea. And so I think at the very end, you just come on up here in the front. You can talk to me one-on-one, and those who want to stick around can stick around. We have the room for another half hour afterwards, so I'll stick around as long as people want to talk. But anyway, let's get on to the talk about SQLite. This is about the gimmes and gotchas. First of all, what is SQLite? I mean, a lot of people are familiar with databases. This SQLite is an in-process SQL database engine. You don't have to launch anything else. It's a zero install. So you don't have another server running. It's completely part of your own program. It's free for any use. It's really small. It can use a small amount of stack space and heap space. It's very fast. Think about doing something like about 100,000 operations per second, so you don't really have to worry about that. It's also very reliable. In terms of testing, I know like a lot of people will complain, sometimes it took me twice as long to write the test code as it did to write the production code. Well, SQLite has 787 times more test code than production code. So for every line of production code, that's 700 times more test code. So it's pretty heavily covered. They have 100% branch coverage, there's DC, MC coverage, there's all sorts of stuff that you'd need for things like avionics and stuff. So it's a really well-tested, it's a very heavily used library. It's the most popular database library in the world. But why use SQLite? I mean, we already have a way to serialize data. We've got Pickle, right? So why don't we just use Pickle, right? Yeah. Well, we can handle large data sets. We can handle data that's too big to fit in memory. You're only writing and reading one row at a time. If we're doing Pickle, you got to read the entire thing up. You got to write the whole thing out, right? We can sort and search efficiently. We can do transactions. We can roll things back, so we can keep things atomic. It's a safe format. If you're familiar with things like PDF vulnerabilities, doc file vulnerabilities, you want a format that's guaranteed safe. And it doesn't matter about 64-bit or 32-bit or little endian or big endian. Your document format, you can transfer from machine to machine to different platforms, and you can still read it with a SQLite engine. And of course, we have concurrency with here. We can read and write and use multiple threads on our database. With something like Pickle, we have to read the whole thing up or write the whole thing out again. All right, so here's some simple SQLite. I basically just copied this directly from the Python documentation. We're going to do something like we import the library. We'll connect to a file. If the file doesn't exist, this will make it. Then we create a cursor, which we can use to read or write that database. I'm going to create a table, insert some data, then commit the changes to the table, and then you can close the connection when you're done with it. Really simple, pretty straightforward, right? Or is it? There's a few hidden gotchas here. Like just going from the bottom up, they say don't forget to commit your changes. So if you don't commit your changes, what happens? They don't actually go in. But they're actually still sitting around. If this were like a function and we raised out of there and did something else and started writing again, when we commit, we'll be committing these old changes as well as the new changes. That's probably not what you expected. If we do have an exception, we want to call connection.rollback, which isn't really mentioned here in the sample, to roll back those changes so we're back to a clean state. And then the default mode for SQLite is auto commit, which means that as soon as you start another execute, the last execute is committed. So that's probably not what you want either. You want to have control over your transactions. So you can start a transaction, do a bunch of changes, and then commit the whole thing or nothing, right? So let's do some improvements on this. First of all, we have a built-in context manager that SQLite gives us. This is one of our gimmes. So on our last talk, we talked about context managers. Everything that happens inside a connection, if we say with connection, it builds a context manager. It will execute that, and if it succeeds, then finally it'll commit it. And if it raises an exception, it'll roll it back. So that'll do our rollback and commit for us. So we actually have less code here. So let's just put a with connection around all those things. And then connection.execute is a convenience. It'll make a cursor, run the command on it, and then return us the cursor. And I put here that's actually more of a convenience, because a cursor, while you have a cursor, nobody else is able to write to that database. So you actually want to close the cursor as soon as you can. This will return you a cursor which you don't see, and then at garbage collection, which could happen sometime later, it'll actually go away. So how can we deal with something like that? To move on, I'll say we'll make a real class for that stock example that they give in the documentation. I did a little utility function there called SQLite value. That's basically because if I put quotes around everything, I don't want to put quotes around a string and have quotes around quotes. But we can get rid of that a little bit later. And then the simple stock option, when you get something back from SQLite, you'll get a tuple, which I have a from row, and then an init, so I can do the symbol, quantity, and price. And so let's take a look. Our stock DB now instead, we'll create it here in our init. And then here's our create table. And we can use the context manager closing to create a cursor. And then as soon as we're done, the cursor is shut. So we don't wait for garbage collection to shut it up. We'll just close it as soon as we exit that with. And we'll do our execute inside that. It's basically the same code that we saw in the sample, but now it's cleaner. And our insert, we'll build that same sort of command that we did before. We'll add the stocks, we have the keys, and we have the values, and then we execute that. Now, maybe people notice that this is kind of unsafe. Do you know? After all, I'm just thinking of the sample here, which was we're going to insert into stocks values, and here are the values that the user gave to us. Now, does anybody see anything wrong with doing that? I mean, I'm taking values the user gave to us, and I'm executing them. You know? So, yes. So perhaps they could be giving us evil values. This is SQLite SQL injection. So if one of those values was something like this, which ends a statement, starts a new statement, and comments out the rest of the statement, that would be a very bad thing to just execute. So instead, what we want to do is use DB API, and you can put in there question marks, and then pass the values in a tuple at the end, where I comma values. So that means that the string that we execute is just a plain string that's completely under our control, and the values are passed in there. And then we don't convert it to Unicode at all, and we can just put in literally that string if that's what their son's name really is. Okay. And lookup is just as simple. This is probably a bit easier way where you can see that where a symbol equals question mark. This is the DB API. So, and then I have to make a tuple, I don't know what you call it, one tuple of muple or something like that with symbol comma. Looks a little odd in Python, but that makes a tuple with only one value. And then one last thing that we're missing here is we could use our connection as a transaction, and I made it private. So let's make a new function which just returns that connection, so we can say with transaction and then do stuff inside a transaction. And then update basically looks exactly the same as insert, so I just kind of skip over that. But here's our class that's basically the equivalent of our stock DB, kind of cleaned up and more usable and safer. But one of the things we wanted to clean up was the auto commit. So that's our default mode. If we're not going to use the default mode, what have we got? Well, we got three other modes called deferred, immediate, and exclusive. And when I saw these, I'm like, what the heck does that mean? I'm sure it's meaningful to somebody. But these are the three modes we've got, and I color-coded these things. And this is a little bit of brain pain, but I promise you it's worth getting through this. And at the end, I have code that takes care of all of it, so you don't have to think about it again. So just relax or strain your brain as you like. Basically, the deferred mode says we can have lots of readers and we can have lots of writers. The immediate mode is that we can have lots of readers, but we're only going to have one writer. And exclusive is we are the reader and writer only. Nobody else can read at the same time. Nobody else can write at the same time. And the color codes here are basically the kind of locks that SQLite will issue as we go. And it's good to become familiar with these locks. The reading lock is the shared lock. And when you start reading, you'll pull up a shared lock. When somebody wants to write, they'll get a reserved lock. They haven't actually started writing yet. So while somebody's got a reserved lock, giving out shared locks is still okay. People can still write. During this time, the writer is setting up the journal and rollback so that they can undo it if they want to, but they haven't started writing yet. But when they actually are going to write, they get the pending lock. So when somebody gets a pending lock, no more read locks are given out. And we're basically waiting for all the readers to drain out. Only one person is going to write at a time, and then the reader is going to be allowed back in the pool. So this is sort of like everybody out of the pool, somebody's going to write, and then when they're done, everybody can pile back in again. So, and then the exclusive lock is now when we're actually being written. Nothing is going to be given out while we have the exclusive lock. And then when we're done, we release that, and then readers can come back in again. So to do that, we'll have to set something like the isolation level. That's normally set to none when you connect to the database. Remember, this was our example.db. So we'll set the isolation level to deferred. I'm just going to cover that one because that has most readers, most writers. The other ones are, simpler than that. And then the other thing we'll want to do is turn on the check same thread to be false. This lets us run multiple connections on the same thing if we're going to be writing. If you were to look up check same thread to find out how to use it, this is the documentation. It's actually not documented, but I have a patch request in for this one. And then the last thing I put in here was I changed the journal mode to wall mode. I love wall mode. This is great. You're going to love wall mode. And we'll get to that a little later. What is wall mode? All right, so wall mode is what lets us read and write to the file at the same time. So imagine your database is the green box, and all the readers are reading out of that thing. Now, when a writer comes along, instead of writing to that thing, they'll write a little delta at the end. And then when they're finished, another writer can come along and write a delta at the end. And readers will still now read the old stuff, plus they have to apply a little delta after they're finished with their read. But they still have a complete database that's fully copacetic, and the writers just keep adding. Now you can imagine we're going to have more and more deltas piling up. Eventually, SQLite will collapse all those writes back together again, and we'll start over again. But in effect, readers don't have to wait for a writer to finish, and writers don't have to wait for readers to drain out. Okay, so how can you get some of this stuff? To get wall mode, you have to be in version 3.8 of SQLite. And depending upon the OS you are, if you're on Mac, SQLite comes with your OS, but it depends on what level you're at. On Windows, you're kind of like in luck and out of luck. There's no SQLite on Windows that ships, but so Python provides one for you. On Python 2.7, you get an older version, 3.6, and the latest 3.4, which is out. I know some people are probably using 3.5, but you get 3.8, so you will have it. And on Linux, I think just check manually. I have no idea on Linux. Somebody? Okay, so the Python one that comes on Windows, you're going to have to put that in anyway. It's just the DLL comes, and you'll be putting in Python anyway, so just drop it in. And to upgrade, all you need to do, to upgrade, all you need to do is just drop in a new DLL. To check the version, there's SQLite 3. Version you can type, and that you might be tempted, but right in the docs it says this is not the version of the SQLite library. Instead, you want to look at SQLite version. That'll tell you these versions that you see on the right. So you can just check, just type that in Python, type that, and then you'll see what you've got. Okay, and then to upgrade, put in a new SQLite. I think this will upgrade you on Mac, and then I don't know on Linux how you do that. But if somebody knows, let me know. Okay, so then our last steps is to be able to do multiple writers. There's basically two strategies here. One is to create a connection per thread, and the other way is to use one connection amongst all your threads. You can only have one set of changes per connection. So you could do the first one, we basically look up in a dictionary to get our thread's identity, which is an int, and then look up our connection. If we don't have one, make a new connection for that thread. When the thread goes away, you can delete it out of your dictionary with on delete. I have more code for this up on GitHub. If you want to do the lock, we change that transaction code that we wrote before to take a lock, let them do their code, and then either commit or rollback. So this is basically the same thing. We're basically re-implementing it, but adding our own lock in there, so that way we can have multiple threads sharing the same connection. And the good news is they both work. So you can go either strategy, whichever one you like. This doesn't seem to make any difference in performance because since you really only have one writer writing at the same time, whether you take a lock yourself or not, if you do the top one with multiple connections, SQLite will lock out the other writers. So you'll still only get one writer at a time. Okay, and that's it for our talk. I have some more, the code and the slides are available on GitHub. And if you have more questions or comments, yeah.
So Anaconda is shipping with 3.9.2, so if you want to upgrade,
yeah. Yeah, and things like the 3.6 versus 3.8, between 3.7 and 3.8, the performance doubled. So dropping in a later version of SQLite, less bugs, better speed, so I recommend it. Okay.
I got one question.
Yes.
So those locks that happen, are they happening at the file level, at the table level, at the row level?
They're at the table level. So at the file level. SQLite puts all your stuff in just one file. And even like in wall mode, it's one file that it's just writing to the end of that file for the deltas.
Okay.
So yeah, and those locks are not in Python. They're actually in the C code, the SQLite library itself, below Python. Yes.
So SQLite.version doesn't tell you the version of SQLite. What does it tell you?
It tells you the version of that module, which hasn't changed forever. So you're looking at the version of the Python code that wraps SQLite below you.
Just a quick reminder that we have microphone back in the back. The reason we have the microphone is that it's being recorded, so people who are online can hear your question as well. So please do ask questions, but please use that mic if you can.
So the question was, what does SQLite 3.version give you? That's the version of the SQLite Python module. So that code hasn't really changed. And they don't, it doesn't expose wall mode, all these things that it doesn't know exist because it was written to be compatible with SQLite version 3.1. And you have to go back to like 10 years to have something that's not thread safe. So the default value of checking for your thread, might as well set it to check thread to be false now. Okay. Does anybody have any questions about ORMs? That's what I got asked last time. Why not use an ORM? No?
Yes.
Why not use an ORM?
Good question. So an ORM can be great because you can just write, A.B equals C.D, and it's all magically taken care of for you. You don't have to worry about your transactions or your lookups or anything like that. The only problem I have with it is that sometimes your performance is really bad and you have no clue why. Because you don't know where your transactions are happening, or that something that looks innocuous is actually firing off 1,000 queries to the database. But if you make your queries explicit, you will know. So, and it's not really complicated to write stuff for SQLite. Okay. Well, thank you all.
Actually, that was perfect timing. Very good. So don't forget that we're looking for feedback. If you have any kind of, not critique, but something creative or constructive, please come talk afterwards. By the way, I thought it was an incredibly good talk. Very, very good. So we didn't have much of a chance to squeeze everything in. We did lightning talks. We did we did another, just only 2 talks. We didn't get tutorials. We did have a little bit of sort of like an auction. We had a T-shirt that was thrown over, but we didn't have a party yet. So we're going to have to find a way of having a party.
And you didn't do the run.
And we didn't do a 5K tonight either. Very good. So as you can tell, it's starting to feel like PyCon. It's kind of like, there's so many things to do. And I go to bed at 3 o'clock in the morning going, I've got to get up in 3 hours because I don't want to miss this talk. So that's what PyCon's like if you haven't been there before. It's actually just a lot of things going on. It's a lot of fun. It's already reserved and booked up this year. It happens pretty early. So I would be on the lookout next year if you want. It's also going to be in Portland next year. It's not that far. We could consider driving up if people want to do such.
You can also, the sprints, which happen the last 4 days, are free, and there's plenty of space, and there's also food and stuff like that too, and that's where you can actually meet all the developers. You can meet the core developers who work on CPython itself. You meet a lot of like superstars in the hallways. I went out with Guido for dinner one night. So
I sat across many tables from him at the. I remember pastries in the middle, just chatting.
Right. So that's also a great opportunity. It doesn't cost you anything.
And I'd point out that it's this year and probably next year. There's a crowd of people that go up on the train before PyCon, and they take the train from here up to there, and they sort of hack around on the train for an extra day.
Okay.
Damn, I just bought plane tickets like 3 days ago. So I didn't know, or I would have done that. That would have been really fun.
Okay.
All right, well, thank you, everyone. I know we're running a little late. We had a half an hour later start today. Grant, did you get a count of everyone? Yep. How many people were here tonight? 110. That's not bad. All right, thanks, everyone. Have a good time. We'll see you next time, and maybe I'll see some of you at PyCon.